M, and it became mvf minus mvo, which is just momentum. Is that not just momentum, mv? So she calls it pf minus po. So I'm just going to write it with f on the left. All right, so this is not the normal form that we leave it in, so we're going to take one more step from that. We're going to multiply. Take this where you are. Have you got that down yet? Have you got this development down? Go ahead and multiply both sides by change in time. And I'm going to erase everything. Multiplying both sides and change in time, what do we get? So write that in your comp books.
I don't have it all down yet.
Oops, it's in your book too. So
Alex, do you want to see mine?
Don't you just need a last equation?
Yeah,
I'll leave the last part there.
it's just up here.
So multiplying both sides by change in time. Brendan, what does this look like?
Change in P equals force times change in time.
All right. The way I remember this is because it looks like the word fat. If this was, if that was an A, does it not? All right. In honor of Fat Friday, change in momentum is fat, and it comes up so much that we gave it a name. For those who read it, what is that name that we gave it, Hannah?
Impulse.
Impulse. So this has its own name. Impulse has the same unit as momentum, because momentum, it's equal to momentum, so it is also kilogram meters per second. Impulse is what you'll be reading about and we'll be talking about for about 3 more minutes. So you're reading again about more about impulse than I will be able to get to today. So impulse is actually this fat over here improves your life. Not only does fat make things taste better, it makes things safer. So let's look at how we can use impulse. All right. Suppose that we have a bat. Can you draw a bat?
Oh, I thought you meant like the animal.
No. A baseball
Okay.
bat and a baseball, the one that broke our window.
What?
We're drawing a bat and a baseball, and we're going to talk about impulse as we do that. So, when you hit the ball with the bat, you want your change in momentum to be very large. Remember, momentum, here's what's in your thoughts when you see the word or the symbol momentum, it's mv. The mass of the ball is not going to change after you hit it, but you want the velocity to change a whole lot. So the pitcher, tosses it in, and you want to send it out much faster than it came in. So you really want the change of momentum to go up when you hit that ball. Anybody play in their youth or now?
Yes.
Baseball or softball?
For like 7
Rec?
years.
Did you?
No. I always wanted to.
I was in the
I know, I
sports
always
group
wanted
when I was
to.
younger.
Alex? You said yes. Jonathan, did you play baseball or softball?
Actually,
Yeah.
A little bit, Brendan?
I played for like 7 years.
No.
That'll do. That'll do it. What position?
I played second base and third base and catcher.
Hannah? No? Alright, just about half of us have experience, so we're going to have to glean from those who played before. So it turns out that we have this equation. We have change in momentum equals fat. So force change in time. It turns out you can only hit it with so much force, right? Suppose you hit it with the maximum force your muscles can do. So that is maxed out. But there's another component to impulse, and that is change in time. How can you increase that when you're at bat? every coach, every
Swing
dad,
faster.
every coaching mother, every coaching older sibling has told you to do what once you hit the ball?
Follow.
Swing.
Step
Follow
Through.
through. Does that make sense? It's like everybody used to hit the ball and drop the bat, right? No, no, no. You hit the ball and you follow through. Why?
Because then you get
Because you get more time of contact. Even though you're sending it out in another direction, there's more time of contact if you follow through. It will increase that change of momentum. Isn't that cool? Now, so here you want to increase the time. What about when you have a car wreck? Let's talk about that. Here, change in momentum is a negative thing because you're sitting along and you're going at the car 30 miles an hour. The car comes to a complete stop. You keep going according to Newton's first law. Say you forgot your seatbelt and you hit the dashboard. You want that impact to be low. So the change of momentum is going to be what it is. You can't control that in an accident. So you're going 30 miles an hour, you come to a stop. That is going to be a change in 30 miles an hour. But this can change up and down. So this, say we're going to change, is going to be 30. We went from 30 to 0. So the change is 30. So what could we do? Force is going to be, we want force to go down. So in order for force to go down, this number has to be 30. So as this goes down, we want it to go up. So what can we put in our cars that could cause the time of impact to be large? Brandon, what can we put in our cars?
Airbags.
Airbags. And they are not helping us because they are soft. They are helping us because the time of impulse, this part of impulse, if you hit the dashboard, is short, making this large. But if your airbag, it creates a long time of impact that puts the force down. So it's not because they're soft and cuddly, it's because of impulse. All right.
I was gonna say they're not soft, are they?
Okay. Do your reading and take notes, and I will see you next week. Thank you, Brandon.